Okay, students, good morning. So last time we have started with a discrete time Markov chain. So let us continue that. So I'm sharing the screen. So last time we have given the definition of discrete time Markov chain, that stochastic process that take on finite or countable number of possible values is said to be a discrete time Markov chain if the future given the present and the past depends on the present only. Then we say that xn is said to be a discrete time Markov chain, and corresponding to that we have obtained the transition probability and make a transition probability matrix, which is known as the TPM. And then various examples we have taken, and then find out the corresponding state space and corresponding TPM. And one example we have taken where in the question uh, we make a transformation of that process into a Markov chain. So that is, we have defined xn such that that is a discrete time Markov chain. Now let us start with the n step. Transition probability. So Pij n is the probability that x m plus n is equal to j given xm is equal to I. So because it is a stationary transition probability which we have already assumed, so therefore this is basically xn is equal to j given x naught is equal to I, because it doesn't depend on the value of m basically. So here also, because this is a probability, so therefore p I j n should be between 0 to 1 for all I and for all j. And for fixed I, because of the definition of the probability, summation over j, summing over this value j, which belongs to the state space p I j n for all possible values, this should be 1. So we can make a TPM also here, that is known as the n step TPM. So Pn, which is containing the elements Pij, that means we have, let us say, state space xn is the Markov chain, okay, and state space, let us say, 0, 1, 2, and so on. Then initial is 0, 1, 2, so on, and finally 0, 1, 2, and so on. This is P00, P01, N, P02, and P10N, P11N, P12N, similarly P20N, P21N, P22N, and similarly by the definition of the probability, sum in the rows, sum in the row should be 1. P00N plus P10N plus P02N plus so on, that should be 1. Similarly, P10N plus P11N plus P12N, that also should be 1. That should also be 1. So all the summation should be 1, as we have already stated here. For fixed I, this summation should be 1. So Now let us see what is the relationship between these n step. For example, m plus n step is there. So can we see, because some m plus n steps are there, so can we see the relationship between intermediate steps also? So that is basically Kolmogorov Chapman-Kolmogorov equation. So P I j n, that means n step. Let us say that m plus n I take. Then this is same as that of summation over k, which belongs to the state space. P I K M P K J N. Okay, and this can be written as summation k P I K N P K J M. Okay, so in this fashion, this transition probability may be written in terms of, because these Pij's are these values, these transition probabilities, n step transition probabilities. So now let us see the solution of this. So what is the ijth element of P m plus n? So that is nothing but Pij m plus n, which is nothing but probability x m plus n is equal to j given x naught is equal to I. Now, using the theorem of total probability, this can be written as summation over k probability x m plus n is equal to j comma x n is equal to k intermediate state k. Okay, where you know that I, j and k, all these belongs to the state space. Okay, so given x naught is equal to I, so summing over k, okay, because using the theorem of total probability, because we know that if we have these a1, a2, let us say n, okay, and some event is there which is e, then probability of e is nothing but summation probability of probability of e, yeah, ai intersection e, summing over I. Okay, so in this fashion this can be written. So in the same fashion we are writing this value also. Is it okay?
Yes, sir.
Okay. Now also you know that probability of A B given C. This can be written as probability of A intersection B intersection C divided by probability of C. Now multiplying and dividing by probability of BC. Combining this is probability of A given BC, and combining the other part, this one, we will get into probability of B given C. Okay, so therefore you know that probability of A B given C can be written as probability of A given BC and probability of B given C. So therefore this can be written as summation K probability x m plus n is equal to j given x n is equal to k, x not equal to I into probability x n is equal to k given x naught is equal to I. Okay, so this is using this probability of A given A B given A intersection B given C is probability of A given B intersection C into probability of B given C. Now because xn is a
Sir,
yes.
sir, so like how to say that A and B are independent? Like that you showed probability of AB given C. It only works when A and B are independent.
No, they need not be
No,
independent.
why independent needed here?
So because probability of AB is equals to probability A intersection B.
Where I have used that? I have not used that thing anywhere because you know that conditional distribution I have used only. Probability of B given C is probability of B intersection C upon probability of C. That is the definition only I have used.
Okay.
Okay, so this is basically nothing but because you know that this is probability of A, B, C, that is probability of A intersection B intersection C divided by probability of C by the definition of conditional probability. Now multiplying and divided by probability of B intersection C, probability of B intersection C. So therefore, this can be written as this quantity with this quantity again by the conditional definition of conditional probability. This is probability of A given B intersection C. Okay, and other part this one with this probability of B given C. Okay. Now next step is Xn is a because discrete time Markov chain. It will forget the past by the definition of the future will depend on the present, not on the past. So it will forget this one because Xn is a discrete time Markov chain. So summation k probability x m plus n is equal to j given xn is equal to k into probability x n is equal to k given x naught is equal to I. Okay, because xn is a discrete time Markov chain. But by the definition, this is nothing but P initial state k, final state j in m steps. And this is P initial state I, final state k moving in n steps. So therefore, this is the thing we have to prove that this is nothing but summation k p I k n p k j m. So we have to show this thing basically p I j m plus n is summation k p I k n p k j m. In the same fashion, similarly you can instead of this xn you can take xm also and you will get the other result also. Now, okay, now can we write them in some matrix form? Now this is p I j m plus n is summation k p I k n p k j m. Now ijth, this is the ijth element of p m plus n, and you can see that the ith element okay, so let us make this Okay, so this can be written as the ith element of this pi 0 n pi 1 n so on, ith element of Pn and the jth element of Pm, capital Pm, jth column of this. So therefore, this will be P0Jm, P1Jm, and so on. So if I multiply the ith row of matrix Pm with the jth column of matrix Pm, what we will get? We will get this value, Pi Jm plus n. So that means this is if I make the matrix of this, if I make the matrix of other side, so we will get P m plus n. This is the m plus n TPM, okay, which whose element are Pij m plus m. This is P n P m, okay, where we are making the matrix of basically the elements Pij n, small Pij n, okay. So therefore, we will get this value basically. So therefore, we will get, if we take our, but we know that P1 is P, TPM is P, just a notation. Already we have done that we are just noting the TPM as P1 or P, okay. So therefore, what will be P2? P2 will be P1 into P1 by this relationship, which is nothing but P into P, which is P square. Similarly, Pn is nothing but Pn. That means the n step transition probability matrix can be obtained by just matrix multiplication of P n times. Okay, so this was the, so let us take an example here. Okay, so let us take an example. Suppose that, so any question till now? Suppose that the chance of rain tomorrow depends on previous weather conditions only through whether or not it is raining today, and not on past weather condition suppose also that if it rains today, then it will rain tomorrow with probability alpha, and if it does not rain today, then it will rain tomorrow with probability beta. So let xn is the weather condition on nth day. Okay, so it may be raining. Weather condition may be because it belongs to whether it rains or doesn't rain. So xn basically takes the value, let us say 0 and 1, where 0 denotes for rain and 1 denotes for not raining. Okay, so this is nothing but state space. 0 and 1 is a state space. Now whether, because xn is a discrete time Markov chain, by the condition, suppose that the chance of rain tomorrow depends on the previous weather condition only through whether it is raining today or not, and not on the past weather condition. So therefore, it is the definition basically of the discrete time Markov chain that future will depend on the present, given the present and future, not on the past values. Okay, so future given the present and past, future will depend on the present only. Okay, so this is the okay. So okay, so this is the thing here. So now, what is the TPM here? First of all, transition probability matrix. Zero, one, 0, 1, because so Pi is basically probability x n plus 1 is equal to j, given xn is equal to I, where I and j belongs to the state space. Now it is given if it rains today, then it will rain tomorrow with probability alpha. So therefore, remember other will be 1 minus alpha. If it does not rain today, 1, then it will rain tomorrow with probability beta. So this is the basically TPM here. Now let us take let it is given that alpha is 0.7 and beta is 0.3. So now calculate the probability that it will rain 2 days from today, given that it is raining today. So what it is asking? First of all, it is given that this is 0.7. So therefore this is 0.3 and beta is 0.3 and this is 0.7. Calculate the probability that it will rain 2 days from today. Elements here are Pij1 basically. So it is asking P 2 days from today. It will rain given that it is raining today. Okay, it is raining. Yeah, 0 is basically rain. P002. That means probability x n plus 2 is equal to 0 given xn is equal to 0. So it is asking this probability. What is this probability basically? Okay, so we know that just we have done that if we have to find P2, so then we can just do the matrix multiplication of this. So therefore this will be 0.7 P into P. Zero 0.7, 0.3, 0.3, 0.7 into 0.7, 0.3, 0.3, 0.7. Now 0.7 into 0.7 plus 0.3 into 0.3, that is 0.58, and 0.7 into 0.3 plus 0.7 into 0.3 into 0.7, that is 0.42, and similarly other value is 0.42, 0.58. Okay, so this is 0, 1, 0, 1. So we have to find P002. So P002 is 0.58. This element. Other way is basically we can make the, for example, transition diagram we can make 0, 1. So in one step from 0 to 0, we can move with probability 0.7, 0 to 0. Okay, so that is 0.7. 0 to 1, we can move with probability 0.3. From 1 to 0, we can move with the probability 0.3. And from 1 to 1, we can move with probability 0.7. So now what will be P002? In 2 steps, we want to move from 0 to 0. So that will be, we can remain in 0 and then remain in 0. That means 0.7 into 0.7. Or that means or means plus here. So we can move out 0.3. Then we will move back to 0 from 1. So 0.3 into 0.3 in 2 steps, because we are talking about in 2 steps. So that is nothing but 0.58. So any question here? Okay, any question till now? Okay.
Yeah.
Okay. So let us move then further. So now we are doing the probability distribution. That means probability PMF, probability mass function of step xn. PMF of step xn. So xn is a discrete time Markov chain with the state space 0, 1, 2, and so on. Let us define the probability that xn takes the value I. Okay. This we can denote just a notation P I N, just a notation. Okay. Then the probability mass function of xn is denoted as P, because I can take value in state space. So this will be P0n, P1n, so on, Pin, so on. So this we can denote as Pn, okay, vector Pn, such that because this is a probability mass function, so clearly summation of probabilities will definitely will be 1. So initial state probability mass function of x naught is, so for initial state this will be P0, because x for x and x naught basically. So this will be P0, 0, P1, 0, and so on, such that summation of I Pi0 is 1. Okay, so this is the for initial state probability mass function. So what is the relationship between these? The probability mass function of xn, step xn, and the probability mass function of x naught, initial step. So we can show that Pn is P naught is basically Pn minus 1 into P. So to show this, we have to show that P0n, P1n, so on to Pin is nothing but P0 n minus 1, P1 n minus 1, so on to Pi n minus 1 into the TPM. P is the TPM. So this is P00, P01, P0I, P10, P11, P1I, and so on. Okay, so now the ith element here is this, and the ith element in the other part, right hand side, this multiplied with this column. So therefore, if this is equal, if Pin is nothing but summation Pk n minus 1 Pki, summing over all the values of k which are belong to state space, then we are done. That means then if we can show this thing, then that is meaning that we have shown this thing basically, because that is the same thing in matrix form. So let us show this. Okay, so we want to show this, for which we can show this thing. So what will be the PIN? This is nothing but probability xn is equal to I. Now, therefore, this will be summation using theorem of total probability, summation over k, probability xn is equal to I, xn minus 1 is equal to k. Okay, so using theorem of total probability. Summing over all the values of k in the previous step.
Sir,
Now, yes.
Sir, in theorem of total probability, we can choose m and n as per our convenience. Like here you have used m as 1. We are just taking breaking it at the very
Theorem of total probability, I think just I have explained. That is basically you have this sample space, you have certain events, let us say A1, A2, so on, AN, such that union of AI is omega and AI intersection AJ is phi, nothing is common, and some event is occurring. Let us say event E is there, then probability of E is nothing but summation common portion with all these. Whatever common portion is there, probability of AI intersection E, summing over this. So this thing I am using. So you know that xn and xn minus 1, both of them are basically occurring independently here. So xn is equal to I, xn minus 1 is equal to k. So this event is basically occurring over this A1, A2, AN. So using that, because this k is there.
Yes, sir.
Is it clear or?
Clear,
So,
sir.
this is summation over k probability x n using definition of conditional probability xn is equal to I, given xn minus 1 is equal to k into probability xn minus 1 is equal to k. So now, by the definition of, because we know that probability of A intersection B can be written as, because we know that probability of A given B is probability of A intersection B, that is probability of B. So therefore, probability of A intersection B is probability of A given B into probability of B. So using that, we are writing this is summation xn is equal to I, given xn minus 1 is equal to k, into probability xn minus 1 is equal to k. Now, therefore, this is summation k, p k I in one step, and this is nothing but p probability mass function k n minus 1. Okay, so therefore we have done prove this thing basically what we want to show. So that means from here we will get your p n is equal to p n minus 1 into the TPM. So this we want to show basically, because ijth element will be PIN here. Okay, so now Okay, so now again recursively applying this, we can also get P n is P n minus 2 P square. In the same fashion, apply this again. P n is P naught Pn, where P is the TPM. Okay, so let us take some examples here. So the TPM of a Markov chain let xn be a discrete time Markov chain with state space S as 1, 2, 3 and TPM as 0.1, 0.5, 0.4, 0.6, 0.2, 0.2, 0.3, 0.4, 0.3. So now states are 1, 2, 3 here. Now, if the initial state distribution for that means for PMF of x naught is 0.7, 0.2, 0.1, that means in the state 1, it is with the probability x naught is equal to 1 is 0.7, probability x naught is equal to 2 is 0.2, probability x naught is equal to 3 is 0.1. Then find, first of all, probability x naught is equal to 2, x2 is equal to 3, x1 is equal to 3, and x3 is equal to 2. So first of all, we want to find this. So this can be written as probability x3 is equal to 2, x2 is equal to 3, x1 is equal to 3, x0 is equal to 2. So therefore, this is probability of A intersection B intersection C intersection D. So as the previous result we have done, this can be written as probability of A given BCD into probability of BCD. Probability of BCD can be written as probability of B given CD into probability of CD. Probability of CD can be written as probability of C given D into probability of D. Is it clear with everyone? As we are doing previously also, probability of A given, okay, in the same fashion. So therefore, this can be written as probability of x3 is equal to 2 given x2 is equal to 3, x1 is equal to 3, x0 is equal to 2 into probability of x2 is equal to 3, this one, given x1 is equal to 3, x0 is equal to 2 into probability C given D, x1 is equal to 3, given x0 is equal to 2 into probability x0 is equal to 2. So, but xn is a discrete time Markov chain. Therefore, it will forget. The future will depend on the present, not on the past values. Similarly, here also. Okay. So therefore, this value becomes probability of x3 is equal to 2 given x2 is equal to 3 into probability x2 is equal to 3 given x1 is 3 into probability x1 is 3 given x naught is equal to 2 into probability of x naught is equal to 2. Probability of this x naught is equal to 2 is 0.2, this value. This is 0.2 and this is P initial state 3, final state 2 in one step. And this is initial state 3, final state 3 in one step. Sorry. And this is P initial state 2, final state 3 in one step into 0.2. Now this is the conditional probability which is given in the TPM P32. P32 is 0.4. P33 0.3. P23 0.2 into 0.2. So therefore this is 0.0048. Now let us find out, let us say what is probability x2 is equal to 3, x1 is equal to 3 given x naught is equal to 2. Now this we want to find out. So therefore this is probability of something A, B given C. So therefore this can be written as probability of A, B intersection C divided by probability of C, multiplying and divided by probability of BC. So therefore this is probability of A given BC into probability of B given C. Applying this A intersection B intersection C divided by probability of BC, that is probability of A given C. Probability of BC divided by probability of C is probability of B given C. So therefore this is probability of x2 is equal to 3 given x1 is equal to 3, x naught is equal to 2 into probability x1 is equal to 3 given x naught is equal to 2. So this will forget the past. So therefore this value is probability x2 is equal to 3 given x1 is 3 because x1 is a discrete time Markov chain. Into probability x1 is equal to 3 given x naught is equal to 2. So therefore this is P33 into initial state 3, final state 3 in one step, P initial state 2, final state 3 in one step. So P33 is 0.3 and P23 is 0.2. Therefore 0.06. So any question till now?
Hello, sir.
Yes.
Sir, how will we find the PMF of X naught in that weather question, in which the probability was defined only in certain situation, like if today it rains, then the probability of tomorrow rain is 0.7. So in that one, how will we define the PMF of x0?
Yeah, that you have to find out, I think, because that either will be given to you or you have to basically find in the real life situation, you have to find out that thing, probabilities.
Of the very first occurrence.
Yes, because either what it is giving that if you know what is given here is if you know the value of the probability mass function of x naught and the TPM. Okay, then you can find out the probability mass function of step xn. Okay, so you should know first of all what is the TPM and what is the uh, probability mass function of x naught. First of all, these should be known to us, or from the question we should make these.
Okay, okay.
Whatever the situation, whatever the problem is given to you to solve, from those you have to first of all find out what is the TPM and what is the initial probability mass function. Once you have find it out those from the whatever the uh, question is given to you or whatever the practical situation is given to you, then from there, if that is the xn is basically your discrete time Markov chain, then you can find out from step xn what is the probability mass function. Okay, so I think let us stop here. So next time I will take, let us say third part is here to find what is probability x2 is equal to 3. Because in this question, for example, initial this is given and this is also given. So either this should be given or you should construct those. For example, in the last class, we see how to construct the TPM. The last class, we have done those, how to construct the TPM from the given question. Okay. Okay, so let me stop here. Okay, I think now my screen is not visible.
No, sir.
Okay. Anubhav Khandewal, 18BT 3F P23. CS 30056. Mika Agrawal.
Yes, sir.
20 EE 10087. Sohini Gupta. 20 IE 10001. Abhay. 20 IE 1000052.
Yes, sir. I am there.
Yeah. 20 MA 20022.
Present, sir.
Okay. 20 MA 20040. Parth. 20 MI 31022. Vidya. 19 EE 10014.
Yes, sir.
Manideep. Yeah. Mandeep. Okay. 19 EE 10042. 19 EE 10042. 19 EE 30021. Pritam Anand. Okay. Okay.